So problem number 2 is only a little bit different from problem number 1. The difference here, though, is that after A and B collide, they are going to become stuck together, which means that they're going to end up with the same velocity. Now, here, our system is going to still include both blocks A and B, which means that we do not need to worry about any forces between them because both blocks are inside the system. So I'm going to do a bar chart. I'm going to start with making a note that I'm going to say to the right is positive. So that means A is going to start with a positive momentum. Again, I'm not going to worry about how big these need to be. And B is going to end up with a negative momentum. And after they combine together, they are going to move to the right, which means that they're going to have a positive momentum afterwards. And one thing I'm going to notice is that because A has a bigger mass than B, and they're going to be moving the same speed, I know that A is going to need to end up with a bigger momentum than B. All right, so let's go ahead and make this into an equation then. So we have the momentum of A plus the momentum of B at the beginning is going to be equal to the momentum of A plus the momentum of B at the end, or afterwards. And then I just need to put in mass times velocity for each of these. So it's the mass of A times the velocity of A at the beginning plus the mass of B times the velocity of B at the beginning. And that'll be equal to the mass of A at the end. Oops. Times the velocity of A at the end. The reason why I don't need to put that it's the mass of A at the end is because the mass is not changing, so I don't want to confuse myself there. All right, so the mass of A is 0.5, so I'll plug that in. And the velocity of A at the beginning is 2. And the mass of B is 0.3. And the mass of B at the beginning is negative 2. And I don't know the velocity at the end. Now, what I do know is because these are stuck together, I know that the velocity of A at the end needs to equal the velocity of B at the end. And because I'm lazy, I'm just going to call all of that V. All right, so 0.5 times 2 is 1. 0.3 times negative 2 is negative 0.6. So 1 minus 0.6 is going to give me 0.4. And then I can add 0.5v plus 0.3v just like you would if they were x's. So this will be the same thing as 0.5 plus 0.3 times v, which is going to be 0.8v. I'm going to divide both sides by 0.8, and I get 0.5 is my velocity. So that means at the end here, this was moving 0.5 meters per second at the end. All right. Then the second part of this question asks for the energy lost during the collision. All right. So if I want to know how much energy is lost, then I need to know how much energy there was in the beginning and how much energy there was at the end. So I'm going to add up the energy at the beginning. So the energy at the beginning, I just need to add the two different blocks together, both A and B together. So I have 1/2 times mass times velocity squared for each of them. And I went ahead and plugged in the mass of 0.5 and positive 2 for A, and a mass of 0.3 and a velocity of negative 2 for B. And then I just need to plug it into my calculator. And I get 1 plus 0.6. And I want to point out that this is a positive 6 because the negative was squared. And my kinetic energy is always going to be positive. All right, so I would have started with the energy at the beginning being equal to 1.6. And then to find the energy at the end, so to find the energy at the end, I'm going to find the kinetic energy of A and B once they've stuck together. And the way I want to do that is just to add their masses together and plug in their velocity. So in this case, they have a mass of 0.5 and a mass of 0.3. And then the velocity was 0.5 that we calculated, and that is going to get squared. And when I type that into a calculator, I get a kinetic energy of 0.1 joules. All right, so that means that I started up here with 1.6 joules, and the energy at the end was 0.1 joules. So that means that I have a difference of 1.5 joules. So I'm looking at these two numbers and I'm thinking to myself, okay, so I started with 1.6 and I end with 0.1. And so my change in energy is going to be equal to 1.5 joules. And that's my answer.